So, in continuation with the previous video, we're going to add a feature and we're going to also see how easy it is to add a feature since we refactor everything. So basically we're going to add two features, and those features will be moving around corners, okay, dynamically. We didn't have to add anything else, of course. Of course it's going to include moving around corners when we are braced and when we are hanging. We can control the offset between the corners, so basically it's an in-between, so a two-step direction, as you can see. Okay, we have one direction that it goes between one point that is over here and the other on the other collider, basically. And yeah, the IK might look a little bit rough at this point, but it's not what we are concerned about right now. We're going to see and how to fix those later, of course. Okay, that's the one, and the other one we're going to see is what we didn't see in the previous video. It's not turning around while we're hanging, but it's actually jumping forward. And as I said, we will not do anything with the IK. Okay, so it might look a little bit rough at this point, but of course we're going to fix those later. So in recap, we need to move around corners dynamically, of course, like this, and the other way is also jumping forward when we are on a hanging position, but there's no manager, so we're basically just jumping forward on empty space. Okay, it will work for this one too. As you can see, this one we're jumping from a manager to another manager, same as here, and if there's empty space we basically just jump there and we are free to do everything else. Let's see our scripts. Of course we're going to work with the climb behavior mostly, and we're going to go into our point script and basically just add the two new connection types, which is hanging jump on air and the actual corner. Probably we're going to add a corner inwards and outwards. We're only going to have I guess you can call it outwards. Yeah, let's call it outwards. So corner outwards. Inwards will be when we are going into a corner like this. Okay, but we will see. Probably that needs to a little bit different logic over there, so we're going to see that on a later video. Okay, hanging jump air when we are jumping on empty space, and the corners. Back to our climb behavior. Now I didn't want to keep adding features, even if it's this simple, because that will make it the videos, you know, harder to watch, and you will have a lot more stuff to think about. But this way it's just way simpler. Let's go to the top. Okay, we're going to use this. Skip depth check is basically the same as skip angle check, where we have over here. So let's bring it down so they are both together. Okay, so depth check is going to skip the check we've added on the previous video, where we also check for the angle of the Z axis when we are finding candidates. The next thing we're going to add is also jump forward neighbor, which is the same like jump back neighbor, but it has a different connection type. The different connection type, we set it inside start. Okay, on start we create a new neighbor, we fix the connection type hanging jump air, and then jump forward custom connection equals true. After that, fixed update pretty much stays the same, everything else stays the same, so we can go directly on point braced and we can start adding the new stuff. Skip depth check, we will start always as false. If we are looking behind, we'll stay the same, and if we are not looking for a manager behind, okay, and we haven't found any points nearby, we are going to check for near manager. So this will check for manager on the left, on the right, up and down. Now, if this returns null, and we are over here, so we do not have a target point yet, and our input direction says that we are moving sidewise, so the x is not 0. Then we're going to say skip the depth check, and also we want to skip the angle check. Oops. Okay, we want to find a manager again, so we're going to use a new function which is look for manager on the corners, and we pass the input direction. When we have our new manager, we're going to set a check manager for corner. So basically it's going to return us a target point from the corner manager, and of course we're going to set the target point to be our target, and then connection type to be, we will set it as corner, and we're going to return, and everything else will stay the same, just in case, you know, we do not want to move around corner. Now let's see the look for manager, before we see look for manager corner, we're going to see the version where it goes when we are hanging. Okay, skip angle check, skip depth check, simple. We were over here. If we this is for jumping forward, so let's not do that. Let's do this. Here's where we want to move around corner when we are hanging. Skip depth check, true. Skip angle check, true. Okay, an exact copy paste with input direction x, and it's also inside over here, since we're already checking if the target point is null, and then we're doing checks based on our input. And yeah, this will probably give a few bugs if we are pressing, although yeah, if we add else, it should probably ignore some stuff. Okay, so it will only run one at a time. If this brings problems, then just remove the else's and basically hard code the z or the x to be 0 depending on which is higher. Okay, we will see this in a bit. So this is it. Look for manager corner. Let's see the function. We pass an input direction. We start with our return value as null. The first origin we're going to check is our current point transform position, and the direction we want to check if we have something first is if we have something on the left or on the right. If we have something on the left or on the right, what that leaves us to is that there's a wall to the left or to the direction we want to move to, so that means we cannot go around the corner. On a later video, as you already guessed, we're going to create this function to work with corner with an inward corner. Okay, we're now focusing the hardest, in quote unquote, that is the outward corner. So the direction we want to look first is we take our transform right, or our current point transform right, and we multiply it with our input direction dot x. We have a function that takes that basically turns everything. It does a raycast from our origin to the direction we want. Okay, basically we have seen this before. Let's see it once more. Okay, it does a raycast, and if it hits something, it returns true. Okay, so we have also a debug draw array. If we haven't hit something, that means it's clear on our sides, so we need a new origin. This time our new origin will be our own first origin plus the direction we have on our sides. Clear forward. We need to check inwards now, so that we are not actually hitting another wall on our sides. At this point it's pretty much the same like look for manager sides. Okay, so we do another raycast. The new direction we want to go is a current point transform forward. So basically the same way we are looking at by one, and we do a debug draw array new origin. Okay, transform dot forward. This is the draw array. Okay, and if it's also cleared forward, so we're not having a wall to our sides. If we do have a wall, then it's probably going to cut over here, so this will not run. So it's not going to look for a manager around the corner if it already have found a wall on the sides. So our new origin then will be our new origin plus our own transform forward. So basically we are around the corner, and now we want to see if there's actually wall around the corner. Okay, so basically we do a raycast. Oops. We do a raycast. And let me... Okay, we are over here. Now don't be jealous of my drawing skills. Okay, I know I'm pretty good. That's a joke, by the way. Okay, we're over here. We check on our sides by 1 point basically, so this is too long. Okay, if there is no wall over here, then we check inwards. If there is no wall also over here, that means it's clear, so we need to check if there is a wall over here. And here's where we actually are at this point in our code. Okay, the new origin will be the previous origin, so yeah, the point where we have already started our raycast plus the direction we are looking for. Okay, so we're going to do a raycast. The corner direction will be the opposite of what our input says, so for the corner direction we're going to take a transform.right multiplied by what we have opposite on our x. The only thing to note over here is that this raycast should be longer than this one, otherwise you're just returning to the exact same point you previously were. So that means there is a slight chance, if you are on the far edge, that you might not hit anything. Okay, so just make this one a little bit larger. 2 points might be a little too much. Okay, and yeah, you need to handle this also on the level design. So if there's another wall over here, okay, of course these two walls are the same thing, but if there was a wall that was more inwards, then your character will pass through the walls, so you do not want that. So in that case you have to take care into level design there. Okay, so we do the raycast. If we hit something that has a get component children manager, then we return it. Notice that we do not have a check for if the manager we hit is the same as our own manager we currently have, and in that case we do not have that because all these points are under the same collider, so they are all under the same manager. But because we skip the depth check, which is the Z basically, if it's on on the threshold angle, and we also skip the angle check, so these transform points look over there and these transform points look over there. Okay, because we skip all that, we can reuse basically the same points and the same manager, and that's why we also take as valid our own manager. Okay, look for manager corner is this. So let's go back to the very pretty much to the top. Okay, on point hanging, not over here. It's the same on hanging and on braced. Okay, look for manager corner and then check manager corner. Code definition. We pass input direction, target manager, and we are over here. Pretty much straightforward. We start with a new neighbor. The target point will start as null. If the target manager is not null, then we're going to go to our target point, into our previous code, return point. Okay, go to definition, pretty much the same. Target point goes to neighbor point, candidate points on direction, and everything in here stays the same as all these videos we have done. Okay, I haven't added anything. The only thing that I've added is inside is direction valid over here. Okay, the depth angle we added on the previous video. So what I've only added is over down here is if skip depth sec, then return true. Okay, so it's going to ignore this little if statement, which checks if it's in the correct angle. We see why we need this on the previous video, and then it's basically we need this mostly for hanging, not braced points. Okay, then we skip the depth check, and it will return true if it's inside these target angles. We still need these target angles because it might return us a point that is over here. Yeah, so that's basically it for corners. Now let's see how we can also jump directly. No, it's not that for corners. We still have stuff to cover. Let me close a few stuff though. Okay, jump forward will come this in a bit. Play animation, go back. Let's close this. We don't need this. Neither this, not this, not this. Let's close this too. Handle mount, yeah, you can add this by now. Init jump forward equals false. It's a new boolean we're going to see for jumping forward. Just add it inside of here. It's just we reset it. We don't want this, neither this. Yeah, I'm just closing this. There's no need to even have them open, so it's just a little easier. Same with init update direct variables. Just add init jump forward to be false. We will see where this goes, and here's where we actually need to do changes. So in transit, okay, new connection type we have, so we can basically add new stuff. Update linear variables, and basically all this is exactly the same. It's an exact copy paste of this one, of an in between. We will use the same for corners. However, where we actually use other stuff for our corners is on the previous part of this code, which is over here, and this goes inside the update connection transition by type. Okay, we remember what this does, and where we are checking what connection type we have, we are over here. So here's where the logic changes. Okay, we have do we need the distance? We do not need the distance. So basically we are moving between one point and another point that are on different. Okay, let's see. Over here we want to move from this point and this point. We cannot move directly in between them because that will be through the wall. Okay, so what we need is an offset point, which is at this point. So the first step will be moving to this point, and the second step will be moving to that point. So how we can know what this point is? Pretty easy. We have an offset. So our offset will start with our current point transform right multiplied by our direction dot text. So that will give us, if we are moving on the left or if we are moving on the right, will give us a -1 or a +1. The exact amount of offset we're going to have is this one. So we take 1 multiplied by 0.5, that means 0.5. We still need to multiply with the direction .x just so that we know, if we are moving left or right. Of course, that will not also do. We can also add a new corner offset to move also a little bit forward. Okay, so it's, on the right it will be around over here, but we can also make him to move a little bit closer inside, so it will be over here. And that's why we're adding also a 0.5 on current point transform forward, so basically on our forward also. Okay, we do not need to multiply this with the direction, which is because either we're moving left or right, we know it will always be forward. Now, the difference though that between braced and hanging is that, these values will be too long for a hanging, if we are on a hanging, okay, and that will look ugly. So we're going to check if our point type or if our current point type is the same as is hanging basically. We're going to override the offsets. Okay, this stays the same, and I'm just multiplying it with 0.1 and the same with transform forward. So we do not go that much and we go only a slight towards the middle position. Desired position then will be the current transform position plus our corner offset. Target state will be between points. The return transition direction will be what it returns from our input direction. Everything just stays the same at this point basically. And we'll play the animation over there. Okay, pretty simple. It's the same with in between, or basically the two-step directions. But the middle point is where it changes a little bit. So let's see it in play mode, and let's see what we have. So we are over here, okay, and I'm pressing left. We are on the middle point. You can see that it went also a little bit forward, and his knee is inside the wall, but as I said, we will fix those later. And the next time I'm pressing like this, pressing left, it will go on point on the next manager, or on the other side if you will. Okay, you can see this as it goes. Of course it will also work the above side, and it will also work on hanging. So let's see when we are also hanging. And you've noticed that we're only adding a few lines of code and we have completely new behaviors. Okay, you can see the offset is just 0.1. So it looks better. If that was 0.5, then it will look completely off. So the next thing we're going to see is jumping on air. And since we're jumping on air, okay, if I press forward, it can't reach this direction, this position basically. So it will jump on air, but if I press space, it will grab on like that. So jump forward. You can see that I have hanging jump air over here, but I do nothing in this. And same in transit, I only call for jump forward, another behavior which we will see in a second what this is. Before we do that, let's see how we can know that we want to jump forward. And that, of course, we can only jump forward when we are hanging, because if we are braced, jumping forward will mean that we are jumping on the wall. Now, it might be fun to jump to a wall, but let's not do that right now. And it probably it's going to give you a concussion if you jump on a wall. So we're over here on point hanging. Target point null. Look ahead to jump. we look for manager forward, and if we have found a manager forward, okay, we do what we were doing before. By before I mean the previous video, and that is jumping on that manager. Now, if the target manager though is null, then we need to jump on empty space. So we assign the neighbor to be jump forward neighbor. The target will be our current point, and we can also say skip angle check, although I think this is redundant. Okay, and we return our neighbor. And basically this says that we want to jump forward. So it goes and does the connection, it updates the connection transition by type, which, as I said, does nothing. Okay, nothing, absolutely nothing. In transition, it comes over here and only updates jump forward, and that's what we are actually going to see. Jump forward, we have also a new boolean init jump forward. Okay, so if we not have not init the jump forward, then we close the root motion. We say we have init also the jump forward. Let's close. No, I wanted to remove this. Or yeah, let's delete it completely. Okay, we enable the controller. It's almost the same as this one, as the jump backwards, but with a few less stuff. Since we're jumping forward, we do not have to worry about rotating our character. Okay, we already have the direction we want to have. So let's go again. We do not want root motion. We have initialized our jump forward. We enable the controller. We set our handle movement, our rigid body to be kinematic at this point. We set a boolean on our animator to jump, and we hardcode our jump type to 55. Remember the 55 because we're going to see it in a bit. And we say enable root movement false. When we have enabled the root movement, we're also going to close the IK, and that's why I've removed it in a bit. Okay, jump forward. And now we have a way, we need a way to basically add forces on our rigid body. So we have this function which we will call on an event inside our animator. So add jump forward force. We close the kinematic, and remember, because when we are closing a rigid body that's kinematic and it's not anymore kinematic, then you need to pass one frame until we can actually use the forces on it. Otherwise, it's going to stay, the forces will not even work. So we have a coroutine, and we also want to say enable root movement, although at this point it will not pretty much matter. So jump forward force, the coroutine, waits for the end of frame and adds force to the rigid body. The force we want is, of course, we're jumping forward, so that means transfer forward multiplied by 5, which is the force, and we also want to add, since it's a jump, we also want to jump also a little bit up, so it's vector 3 to up multiplied by 2, and the force mode will be impulse. And that's it. I have So the last thing we need to see is stop climbing, which is we will also call inside an animator event, and we also, the only thing we need to add is init jump forward. Okay, that's it. I think it was pretty painless. It's pretty straightforward. Basically, it's just a matter of adding the stuff and resetting the variables on the correct place. Okay, so let's see the animator. On the animator, the only thing new we've added is this one, hanging to jump on air. Notice that this is not, it's the same animation, but it's a duplicate of the previous animation. It's not the exact same animation, and that is because we have different animation events. Okay, and the transition type will be jump to true and equals 55. Similarly, because we're using the jump and jump type, we also need to add another check in the transition to jump climb, where we have all our different animations, and that will be jump type not equals 55. If you do not add this, then it will first go into this state, so it will never run this, so you're going to looking at a dead stop. Okay, and it just transitions X, just exits our climb state to go on air, as you can see over here, with just exit time, and it will do something like that. Yeah, it might look a little bit rough over here, but when you are watching, when we are playing, you're probably not even noticing. Okay, and let's see the animation events. Character controller, animation, and oops, the second time this happens. Hanging to jump on air. The first event will be add jump forward force, and basically this one goes where you want to stop climbing. I think a frame after just works fine. If you want to put it on the end, it's entirely up to you. I think over here it also works fine. And as I said, hugging to jump on air and hugging to jump, they are the same animation, but you should treat them as completely different ones, because hugging to jump only has one animation event, which is enable root movement. Okay, if you use the same animation without duplicating first, then you're going to have problems and you're going to fall into a dead stop. Okay, and stop climbing and that. So let's test it one more time. So yeah, let's see it all one more time. Okay, we pretty much have covered a lot of stuff. We're almost at 360 degrees type of movement. Okay, we can move, we can jump on air. Let's see this, if the arcade now will work. And yeah, you see that because I've removed the arcade only when the enable root movement is enabled, then I can jump, and of course I can jump from over there, so let's jump backwards. Okay, I think we have covered inside this climb system. We're almost like a few cases away from being complete. Okay, so we're only looking for extreme cases at this point. And yeah, I don't know how many parts we have left on this, because we have, as you can see, we have covered everything. Also, when we want to move on a corner and there's nothing over here, okay, nothing happens. Let's see the debug draw ray also, because I think it's interesting to see what happens when you're on a corner. I didn't think this much a lot. Okay, you can see this is the first one is from the neighbor managers, and this is the debug draw rays for moving on a corner. So I think that's it. You know what to do. Hit that like, hit that subscribe if you want to see more, and of course if you actually want to see even more and you want to help me too, then consider supporting me on Patreon or by grabbing a project or two from Gumroad, so we can continue making all these nice videos and keeping them free basically for everyone to see. So I'll see you next time.